Inshallah, in today's class, inshallah, we are going to discuss about the diagonalization of a matrix. About the diagonalization of a matrix. First, we have to understand these steps. They are actually these 4 5 steps. In first step, we have to find the eigenvalues, and the second step we have to find the eigenvectors. These two steps we already have done the questions in the previous classes. First we will find the eigenvalues, then second step we will find the eigenvectors. After that, the third step we will find the model matrix. We write the model matrix. The formula of the model matrix will be P equals to x1 x2 x3. x1 x2 x3 are the eigenvectors. So the third step is we write the model matrix P equals to x1 x2 x3, and the next step we have to find P inverse. We have to find P inverse. We will use calculator to find P inverse. After finding P inverse, we write the formula diagonal matrix. The formula of the diagonal matrix will be D equals to P inverse into A into P. P inverse into A into P. The diagonal matrix D will be P inverse into A into P. P is called the model matrix, which transforms A into D. See here, this when we multiply P inverse into A into P, we always get the matrix, diagonal matrix like this: lambda 1 0 0 0, lambda 2 0 0 0. These are the eigenvalues in the order, the sequence we have taken. No? The first value will be here, the second value will be here, the third value will be here. So if we multiply these three matrices, we'll surely get the matrix, diagonal matrix as lambda 1 0 0 0, lambda 2 0 0 0, lambda 3. This will be the eigenvalues taken in order. Now see, this is the method of diagonalization. In questions after diagonalization, the question will be asked like this: also find a power 4, a power 4, or a power 5, like this, or a power some number. Then we have to change this. Watch carefully. You bring this 2 here. The formula of D is P inverse into A into P. If you bring this 2 here, it will be A equals to P inverse on this side will become P, and P on this side will become P inverse. So the formula will be A equals to P into D into P inverse. P into D into P inverse. In the same way, suppose we have to find A power 4. When you apply A power 4, we need not have to change anything. This P and P inverse you write as it is, P and P inverse as it is. For this you have to apply the power 4 for D. Suppose you have to find A power 5, so A power 5 will be P into D power 5 into P inverse. Only for this D we have to apply the power. Okay, let me see this by doing one example, inshallah. Let me do one question in detail. See here, diagonalize the matrix. So let me start like this. How to, first we have to find eigenvalues. For that we take the characteristic equation. The characteristic equation is, we already know this is the formula A minus lambda equals to 0. Okay, so what will be A minus lambda? With these three diagonal elements we'll get minus lambda. 1 minus lambda, 2 minus lambda, 3 minus lambda. The remaining numbers will remain same. So you write like this: 1 minus lambda, 0 minus 1, 1, 2 minus lambda, 1, 2, 2, 3 minus lambda equals to 0. So let me expand this determinant. So we already know how to expand. Let me take first 1 minus lambda. Now you hide this column, multiply this 2 minus this 2, multiply these two numbers, so we get 2 minus lambda into 3 minus lambda minus 2 into 1 2. Then we have to take this with negative sign. No need to write anything because 0 into a number will be 0. This is 0. So 0 into a number 0. The next one is minus 1. So minus 1 into. Now you hide this column. Multiply this 1 2s are 2 minus 2 into 2 minus lambda equals to 0. Now when we solve this, we'll get a cubic equation in lambda. So you write this as it is: 1 minus lambda into, multiply this 2 3s are 6, plus into minus, minus 2 into lambda, 2 lambda, minus 3 into lambda, 3 lambda, minus into minus plus lambda square, then minus 2. Leave this minus 0, minus 1 into 2, minus into plus, minus 2 to the 4, minus into minus, plus 2 into lambda, 2 lambda equals to 0. Now you write this, first you write in this lambda square, minus 3 lambda minus 2 lambda will be minus 5 lambda, then 6 minus 2, 6 minus 2 will be 4 lambda square, minus 3 minus 2 minus 5 lambda, 6 minus 2 is 4, minus 1 into, right, first lambda, 2 lambda, 2 minus 4 is minus 2 equals to 0. Now multiply this, 1 into lambda square is lambda square minus 5 into lambda, 5 lambda plus 4 ones are 4. 1 into lambda square is lambda square minus 5 lambda plus 4, minus into plus, minus lambda cube, minus into plus, minus lambda cube, minus into minus, plus 5 into lambda square, minus into plus, minus 4 lambda. See here, minus lambda cube, minus into minus, plus 5 lambda square, minus into plus, minus 4 lambda, minus into plus, minus 2 lambda, minus into minus, plus 2 equals to 0, plus 2 equals to 0. So let we write in the order wise. First we write let lambda cube minus lambda cube, then lambda square, 5 plus 4, 5 plus 1 is 6, 6 lambda square, then minus 5 lambda, minus 6, 9, minus 2, minus 11 lambda, lastly numbers 2 plus 4 is 6 equals to 0. You take minus common from this, you take minus common from this. If you take minus common, this will become plus, and this will become minus, this will become plus, and this will become minus, equals to 0. Now we got a polynomial equation, cubic equation, so we have to take this using calci. Okay, we already studied. First let me start now. How to start? First you take the mode value. When you take the mode, you will have the fifth number as equations. Fifth number as equations. You take the fifth value, and we got these three equations. Sorry, four. First, second, third, fourth. The fourth one is cubic equation. Ax cube plus bx square plus cx plus d equals 0. So we take the value of 4. Now we have to enter the coefficients. Here we have 1. So enter 1 here, equals to, here we are having minus 6. So enter this minus 6, equals to, then we are having 11, equals to 11, equals to, again lastly minus 6. So we'll get the values of lambda. We'll get the three values because it is cubic equation. So lambda equals to 1. First value got 1, second value 3, then third value 2. I'm writing always 1, 2, 3. So these are the three values of lambda. These are the eigenvalues. So we finished with the first step. Therefore we write eigenvalues are lambda equals to 1 comma 2 comma 3. Now we have to find the eigenvectors for lambda equals to 1, lambda equals to 2, lambda equals to 3. Now for eigenvector we take like this. Let x equals to x1, x2, x3 be the eigenvectors, Suppose we write like this, xi, we have three vectors now for eigenvectors for lambda equals to 1 comma 2 comma 3, where I equals to 1 2 3, and that is x1 x2 x3. Let be the three vectors for lambda. So let me start like this. We have to substitute in this a minus lambda I into x equals to 0. We have to substitute in this matrix a minus lambda I into x equals to 0. We are already having a minus lambda I here, so write as it is, but this is the determinant. We are writing matrix here, so you write matrix like this: 1 minus lambda 0 minus 1, 1 2 minus lambda 1, 2 2 3 minus lambda. This is a minus lambda matrix. Into x we take x as x1 x2 x3 equals to 0. Now we have to use the three cases. What is the first case? For lambda equals to 1, we will get first vector. For, let me write like this: for lambda equals to 1, for lambda equals to 1, then we take lambda equals to 2, lambda equals to 3. If we keep 1 here, 1 minus 1 will be 0 0 minus 1, 1 2 minus 1 will be 1 1, 2 2, 3 minus 1 will be 2. Now into x1 x2 x3 equals to 0. So if you multiply this, you will get three equations. How to multiply? Row into column. So if you multiply like this, 0 into x1 will be 0x1 plus 0x2 minus x3 equals to 0. 0x1 plus 0x2 minus x3 equals to 0. 1 into x1, x1 plus x2 plus x3 equals to 0. x1 plus x2 plus x3 equals to 0. And lastly is 2 into x1, 2x1 plus 2x2 plus 2x3 equals to 0. Now watch carefully, these two equations are same. If you take 2 common here, it will be x1 plus x2 plus x3 equals to 0. So these two we cannot use, we have to use 1 and this, because these two are same equations, we cannot solve it. Let me solve this two. How to start? We are using cross multiplication method. We have to start from the middle value, 0 minus 1 0 0. Watch here, 0 minus 1 0 0. Start from the middle and end at the middle, 0 minus 1 0 0. Here also 1 1 1 1. Start from the middle and end with the middle. You take here x1 x2 x3. So let me cross multiply this one. See here, x1 divided by 0 into inverse 0 minus into minus plus, it will be 1 equals to x2 by minus 1 minus 0 equals to x3 by 0 minus 0 0. So we get like this, x1 by 1 equals to x2 by minus 1 equals to x3 by 0. So actually this is not the actual value, these are the ratios. We can have many values for x1 x2 x3, but we take this one value as, we take like this, let x1 equals to 1 minus 1 0. We take the ratios 1 minus 1 0. We take into k because it's constant, we can have many ratios for this, but we suppose k value 1. You no need to explain everything. Let you write like this, let x1 equals to 1 minus 1 0. So we got the first vector. Similarly, we have to find another two vectors. Now let me take for lambda equals to 2. If you put lambda equals to 2, what will be here? 1 minus 2 will be minus 1 0 minus 1 1. 2 minus 2 will be 0 1. 2 2 3 minus 2 will be 1 into x1 x2 x3 equals to 0. See here, if you put 2, 1 minus 2 minus 1, 2 minus 2 0, 3 minus 2 will be 1. Now again you multiply the matrix row into column. So if you multiply row into column, we get minus into plus minus x1 plus 0 x2 minus x3 equals to 0. x1 plus 0 x2 plus x3 equals to 0. Now next one is 2x1 plus 2x2 plus x3 equals to 0. Now watch carefully, the first and second equations are same. If you take minus common, it will be x1 plus x3, x1 plus x3. These two are same, so we cannot solve these two equations because these two are same, only one equation this is. So let me solve these two. Let me solve these two equations. Okay, now start with 0 0 1 1 0. We know the method, start from the middle and to middle, 0 1 1 0. Here will be 2 1 2 2 2 1 2 2. Here x1 x2 x3. Now let me cross multiply this, x1 by 0 minus 2 will be minus 2, 0 minus 2 will be minus 2. Now x2 by 2 minus 1, 2 minus 1 will be 1 equals to x3 by 2 minus 0 will be 2. Now watch once more what we have done. 0 minus 2 will be minus 2, 2 ones are 2, 2 minus 1 will be 1, 2 ones are 2 minus 0 will be 2. So we got the second vector, x2 equals to minus 2 1 2. So now we have to find the third vector. Now see here, for we have to solve now for lambda equals to 3. If we put lambda equals to 3 here, 1 minus 3 will be minus 2 0 minus 1 1, 2 minus 3 will be minus 1 1, 2 2, 3 minus 3 will be 0 into x1 x2 x3 equals to 0. Now let me multiply this matrices row into column. So we will get minus 2 into x1 minus 2x1 plus 0 x2 minus x3 equals to 0. The second one will be x1 minus x2 plus x3 equals to 0. And third one is 2x1 plus 2x2 plus 0 x3 equals to 0. Now let me solve first and second. 0 minus 1 minus 2 0. 0 minus 1 minus 2 0. 0 minus 1 minus 2 0. Here minus 1 1 1 minus 1. Second one minus 1 1 1 minus 1. Now let me solve this one. Ratios. Suppose this is x1 x2 x3. x1 by 0 into n number, 0 minus 1 is plus 1, so minus will be left here. x2 divided by minus 1 is plus 2, it will be equals to x3 by plus 2 minus 0 will be 2. So this is x1 by minus 1 equals to x2 by 1 equals to x3 by 2. So the third vector we get as x3 equals to, so this is the third vector, minus 1 1 2 minus 1 1 2. Now let me continue. Now after getting these three vectors, we got these three vectors. Now we have to find the model matrix. We have to write model matrix. So it's very easy, we know, just return model matrix is denoted by p. P equals to x1 x2 x3. This is the model matrix. Suppose in some time the question will be asked only about the model matrix, then we just substitute the values and left it. We will not diagonalize. Find the model matrix means this is p equals to x1. X1 is here the first vector, 1 minus 1 0. X2 x2 is the second vector, minus 2 1 2. X3 is the third vector, minus 1 1 2. Okay? So we got this p. The next step we already discussed, we have to find p inverse. We have to find p inverse. Let me take p inverse from calci. Okay, let me take p inverse from calci. So actually what we have to do, see here, first we have to take, sorry, we have to see whether we are having matrices or not. Okay, take first mod, and you see, after taking mod, you see the sixth number is matrices. So take the value of 6. So let we take, we cannot have p here, we take matrix A. So we take first matrix A. So we want 3 by 3 matrix, 3 by 3 matrix. So we take one. Now let me write this, input this, we will substitute the values. What is the value here? 1 1 1 equals to, the next number is minus 2. Minus 2 equals to minus 1 equals to, again we have minus 1 here, minus 1 equals to 1 equals to 1 equals to 0 equals to 2 equals to 2. Now we substitute the value, sorry, equals to 2. So we got the matrix A. We have to substitute the matrix A here. So let me do one thing. You take out this AC. Again we take matrix, we can take from here, shift and take 4. We got the matrices. The third is matrix A, so we take third. Now we got matrix A. We got matrix A. We want inverse. We want inverse. You see here, we are having inverse. Here we are having inverse. You see here, this is the inverse. Inverse here, x inverse. So you take x inverse. You get matrix A inverse. So matrix A inverse. Now we got this value. See here, the first value is 1. Sorry, the first value is 0. Then minus 1. It is given 0.5 means 1 by 2, minus 1 minus 1 0. Here 1 1 1 by 2. This is the inverse. This is the inverse. It is, so we have taken the inverse from calcium. Okay. Now next step, we can write this as it is, or we can take out 2, multiplying dividing by 2. We can take out 2, or else we can write as it is, no problem. Then the next step is last step, diagonal matrix. Therefore diagonal matrix, diagonal matrix diagonal matrix is denoted by D. So its formula is P inverse into A into P. So D equals to P inverse, just we have got this value from calci, 0 minus 1 1 by 2, minus 1 minus 1 0, 1 1 1 by 2 into A. A is the given matrix. A is the given matrix. So we have the given matrix 1 0 minus 1 1 2 1 2 2 3 into P is the model matrix. Just now we have written the P, 1 minus 2 minus 1 minus 1 1 1 0 2 2. So if you take in calcium, this matrix has A, this matrix has B, this matrix has C, you will get the diagonal matrix. No need to do all thing. What we'll get here is in the diagonal elements, principal diagonal elements, we'll get the values of lambda. First we have taken lambda value 1, so we'll get 1 here. The next value we have taken 2, so we'll get 2 here, and third value is 3, so we get 3 here. The remaining numbers will be 0. This is the diagonal matrix. So no need to do everything. If you take this as A matrix, this as B matrix, this as C matrix in calcium, you multiply this one, you'll get like this. So whenever you get the answer will be like this. You will get the eigenvalues here. Eigenvalues here, the first value we have taken 1, so we will get 1 here. Here we will get 2 here. Here we get 3 here. Okay, and the remaining is 0. So diagonal matrix means only so values will be in the diagonal, the remaining values will be 0. So this is actually diagonal matrix. So now we got the diagonal matrix. This is the method of diagonalization. One more question is left, we have to do that question. You see here, the next question we have to find a power 4. So do one thing, you bring this 2 here, we'll get A equals to, you see here, P inverse here, it will be P into D into P inverse. If we write D, P inverse will be first matrix. If we write A, P will be first and the last will be P inverse. The reverse of this, P will come here and P inverse will be here. So A power 4 means, you have to write D power 4. You write this as it is, P into D power 4 into P inverse. So A power 4, using this we have to write this P. So A power 4 equals to P. We already got P, 1 minus 2 minus 1 minus 1 1 1 0 2 2. This is P into D. D we got 1 0 0 0 2 0 0 0 3 power 4 into P inverse. Now what is the value of P inverse? We got this here, 0 minus 1 1 by 2 minus 1 minus 1 0 1 1 1 by 2. Now see here, we have to change this one now. We write this as it is. 1 minus 2 minus 1 minus 1 1 1 0 2 2 into, now see here, just we have to apply the power. 1 power 4 will be 1 0 0 0. Now you watch here, 2 power 4, 2 power 4 will be 16. If you multiply, you will get like this only, 0 0 0. 3 power 4, 3 power 4 will be 81, will be 81 into, now see here, let me do the last step. Now this, you write this as it is, 0 minus 1 1 by 2 minus 1 minus 1 0 1 1 1 by 2. Now the little work is left, you try by yourself. See here, now how to complete means, if it will take long time if I do it this all. You take this matrix as matrix A in the calcium, this matrix as matrix B in the calcium, and this matrix as matrix C in the calcium. You take matrix A this, matrix B this, matrix C this. Now multiply matrix A into matrix B into matrix C. So you will get, if you multiply, you get these values. You just do by yourself because it will take long time. So this will be minus 49, minus 50, minus 40. This will be 65, 65, 66, 40. And lastly, this is 130 and 130 and 81. So if you multiply, you must get this values. Okay, this is A power 4. This is A power 4. What we have to do, suppose this A, this has B and this has C in the calcium, and you multiply this A into B into C, will get this value. So this is a long question, so we just do one question. Actually this diagonalization depends upon the algebraic multiplicity and geometric multiplicity. When these two are equal, we can diagonalize, otherwise we cannot diagonalize. But we don't have scope here to discuss in detail. Let me see afterwards, after few parts, if possible I will discuss about the algebraic multiplicity and geometric multiplicity. Just now I have explained you how to do diagonalize the matrices. Okay, I request you to try one or two questions like this to get the perfection. Same question you try by yourself, some other numbers, so you'll get the perfection. Try detail. Okay, so inshallah we will continue in the next class. If the given matrix is symmetric matrix, then the diagonalization will be little changed, that is called orthogonal reduction method. So inshallah we will discuss orthogonal reduction method in the next class inshallah. So I request all my students to like this video, share and subscribe to your friends inshallah. We will continue in the next class inshallah.